Cool. Okay. Good morning, everyone. So today we are going to discuss this test trimming problem. Okay. After that, we'll go to the linked list problem. So we covered more than like 8 or 9 problems in strings, right? So this is the last one I would cover on strings. Um, so so this is something like in most of the newspapers or even in the blogs, we will see that, right? In the home page, you will see the news, some of the just few lines of the news, and then they will add the read more, right? That's what it is. So how to do that for the different string lengths? Okay, so you have given a text file and write a program that outputs its lines according to the following rules. So every line need to follow this rule. First one is, if the line length is less than or equal to 55, just print the without any change, print the line without any changes. Let's assume that we we have a home page or something where we are showing number of news heading and at least 55 lines of text about the news. Okay, so if you are thinking that way, we can understand why it is happening, why these rules are made like this, right? So let's say the text box or the text area or something that control only, we put a size that can allow only to show 55 characters. So that's why we don't want to cut, we don't want to show the entire string. We have to cut the string if the length is greater than 55. So if the rule number 2, if the length is greater than 55, change it as follows. It's not like cutting exactly 55 and just showing on the screen, right? It may not look good as well. If you cut just for 55 characters, you may cut the word, right? And sometimes it may not look good. It doesn't look good when for the readers. So the idea here is trim the line to 40 characters. So out of 55, we are trimming, rather than taking 55 characters, we are taking only 40 characters. Okay, and then what we are doing is basically we are adding 3 dots and then something like this read more in this brackets kind of thing. So if we count all these characters like 3 plus 4, 5, 6, 7, 8, 9, space is 9, 10, 11, 12, 13, 14. So exactly like there is a space here. I think yeah, there is a 15 here. So exactly if you count these characters, it is another 15 characters. So 15 plus 40, it becomes 55, right? So again we are putting 55 characters, but 40 characters of the actual string, and we are adding something like there is more than that, so please read more. You got it? So finally, the area will only allocating. We are only putting 55 characters. So that is the reason we are cutting to 40 characters. But here one more thing. Even if you cut at the 40 characters, you may cut the word. It doesn't look good. If you are cutting at a word which is not like may not be the user may not be able to read it. That's why. So if there are spaces in the resulting string, trim it once again to the last space. So the space should be trimmer too. So basically, if there are spaces in the resulting string, uh, I think the rule is a little bit confusing. So let I will explain with an example. So if there is a space in the resulting string, trim it once again. So what is meant by that is, let's say we want to cut this, right? If we cut this to 40 characters, okay, and then we have to cut to the last space as well. So let me do this. Do we have, is it clear so far? Any questions?
Yeah, good.
Clear, right? Okay. So character count. There is a character count online. So let me open with that. Okay, character called world count. Yeah, let's open this. Let's put here. Yeah. So now here is this string, right? So first string, like this is the input. Input has 2 lines. So output also need 2 lines. Okay. So now let's look at this one. Tom's mouth watered for apples, but he stuck to his work. Now, how many characters? 59 characters, right? So 59. So the rule is, so this rule is failed. The length is less than 55? No. Now, the length is greater than 55? Yes. What we need to do? First, we need to trim the line to the 40 characters. That means, let's trim all the way to 40. I'm just removing characters. So 40. Okay, look at that. It says but H, right? So we cut to 40 characters. Now the problem is we need to add something like this. We need to add this one, read more, to this. That's it. Actually, we need to do this, but it doesn't look good here. Look at this. This storm mouth watered for apples, but H. What is that? H with people may not know what is that H, right? Right. So that's why what we need to do is before we putting the read more, we need to trim this, trim the string to the last space. Last space. Let's say we got something like a HERE. This is the word there. So we will have only three letters D, something like, or two letters. We don't care how many letters it is. What we all care is we need to remove those many characters until the last space, and we will remove that space also, and there we will put this one. Now it is so interesting, right? See, Tom's mouth watered for apples, but it looks like, oh, something is happening. They want to read more, right? So this both it looks good. There is no word cutting, and as well as it is giving some insights. So now the total length is 53. That is fine. 53 max is 55, but we are putting only 53 characters. That is still okay. Okay, that is the main thing here. So if there are spaces in the resulting string, trim it once again to the last space. Let's say something like this. The line is something like let's say more than one spaces are there. So let's say in 40 characters, right? So in the first example, so in this 40 characters, so 40. So what he's saying is if there are any spaces, something like three spaces or anything, so we need to cut all the way to the last space. That's what it is basically. If any word was cut, we need to trim all those characters once again to the last space. We should rename this, like, if the rule number two is, I think it's not working as here. That's fine. So if the resulting string has a broken word, okay, trim it once again to the last space. The space should be trimmed too. Okay, is it clear? Is this statement clear?
Yeah.
So that is the thing here. So we need to make sure we don't want to cut any word. If the resulting string has broken word at the end, trim it once again to the last space. Okay, so how to do this? So let's say this is a program where we are manipulating on the blog site or something, and here it's not the program that we need to do with absolute character arrays or anything. Just you can use whatever the methods available for the strings. So in any language there are multiple methods available for the strings. First one is length is the one, and you can also do uh, replace is there. I think substring is there, all those things. These are the very common methods. I know there will be little bit change in the method names, but replace is basically it will replace this. I don't think we need replace. So we can use length, we can calculate the length, we can substring, we can provide substring where we will provide the string, and we will also provide starting point and the number of characters you want to cut. That is substring, and also you can use string builder. You can use whatever the functions you are available. That is available. There is no restriction that don't use length or don't use substring. Nothing like that. We can use whatever we want. Okay, and we need to achieve this. So, any ideas how to do this? Let's assume that let's work for the single line. So we got the input something like this. We want to print this output. How to do this? Just for single line. Just share your thoughts.
So read the entire string,
Okay.
like a read line, or if
Yeah.
you want to go for a read line, you can read entire line,
Okay. And then what you do?
and uh, go by character. I mean, traverse character by character,
Okay.
and count. Have a counter
Why,
in
why do you
between.
need to why do you need to do character by character? I clearly said you can use any functions. You can use string or
Oh, functions.
string.
Oh, okay, okay,
That's
okay.
what I'm
That's fine. That's
telling
fine.
here. That you can use
Substring. That's
whatever functions available. You no need to
yeah.
We can
worry about.
directly go to 40 index and check is there any
Right.
space on the 40 index. If
Okay.
not, cut move up to the space
Yes.
character
Yeah.
Okay. So 40 index, you can go to 40 index and check what is there. Let's say in the 40 index it is HE or H. Okay. So and then how do you know which where is the space? You need to go back, right?
back.
Okay. So
So
And
if we have a
the
space car, just append read more to it.
okay. So do you guys know about these functions? There is other these functions also available in pretty much every language. Index of, last index of,
last index. Yeah. Yeah.
basically
Yes.
index of something like let's say W.
String comma.
So
Yeah.
if yeah, string comma, basically string comma W or something. Let's say it will
Yeah.
it's a mouth MOUTH, something like this. Then what it does is it will start from the beginning and it will find where is this word available. This word starts
Yeah.
from 0, 1, 2, 3, 4, 5, 6, right? It will give the
Yeah.
index of that six, something like that. So that is also there. These functions. So last index. Do you guys know about last index? What it does?
Last index. I think the entire string
Last index is
from the
something.
last.
Last
Uh,
index is basically from the last. Basically, let's say if I put B here, it will start the search from the ending. Where is B? B
okay.
is here. Okay, B is here. The first B is here. Like it says, it will find out. There will be another B, but it will stop here until it finds that character, whatever you give it. Let's say if you give but, it will give exactly the index of the but. Or if you just B, so it will give the index of the B, the first B that appears from the last. Okay, these are all available in this in the library to use. So then how do you do this? Because if you are going with character by character, okay, it's unnecessary. We have methods to use. So if you go directly to string of let's say string of 40, right, you can go string of 40 and you will see some character H is there, let's say. Then how do you find the space character before that? Again, you need to loop one more loop and going back, right, from 40 to 39, so all the way to 40 to 0 until you find a space, right? It's like you're navigating all the way here and then you're navigating again back. Let's say there is no space, so you will go all the way to again to the front. So why do we need to do all this? Can we use any of these functions? Okay, any
I
idea?
think yeah. That's good. Substring. If we go with the substring,
Very good.
pass the enter string and uh, mention the character length. How much we want to substring, like 40 character till 40 characters.
Exactly. So we'll do is first thing is we'll do the substring. We'll provide the string where to start from 0, where to end,
Zero
take the 40 characters first.
40th.
Just to take the
Yes.
40 characters. What will happen is it will take all the way 40 characters until here, right? So that is the result. So we will put in another string. This is the intermediary results. It's not final result. Okay. Now what we do here? Now we got the 40 characters and this is the string. So next one is, which method is better to use? So now we don't know whether this is a space or this is another character in the middle of the character, right?
Yeah.
Last index.
Last index of, yeah, last index of what?
Space.
Space, exactly. So what we will do is, so we'll do that. Let's say this is R. This is a intermediary result R equal to just a, okay. So we'll find last index will provide R, string R, and a space. We just need to find the space. Then what we do, we'll get, let's say this is 0 to 39, right? 40 characters means this is 0 to 39, and we will get the index of this space. This is 38. Okay. Now you got the 38. Let's say this is SPA last, LAST last, SPAC space index, last space index equal to 38. Now what you do? You got the index. Okay, now what you do? What they said? Trim. If the
We
result
need
string
to
has been broken,
trim out. Yeah.
yeah, trim, not trim. TRIM, not trip. I typed trip here. Trim it once again to the last space, and the last space should be removed. So what we need to do? We need to take all the way from here to here, right? How do you do that? Again, which method will be helpful?
Same substring.
Substring. So same
Substring.
thing. Again, we will use substring, and then substring. It's just a writing of
After
couple of methods only. So substring, we need to provide R
from, yeah,
from where, from 0 all the way to
38.
38. 38. If you take all the way to 38, you will get the space as well. We don't need the space.
38. Yeah, 37. I think. Yeah.
38 minus 1. We don't know what it is. It could be 38.
Yes.
It could be, it could be 20. Whatever the last space index minus 1,
Yeah.
isn't it?
Correct.
So then what we'll get? Then we'll get the entire string all the way to from here to here. That will be the R. Let's say R again. We are replacing R. Now we got it. Now finally
Yeah.
what we need to do? We need to append this one.
Substring. Yeah.
No, no, it's not substring. It's just you can append string dot builder. If it is string builder,
Yeah. Yeah. You can append directly.
you can
Concatenate
append.
and
So we
append.
can
Yeah.
use all
String.
those methods, right? So append, you can use this method. So string dot append. So finally the result equal to R. I think string builders sb dot fpnd string builder. So you will append. So string builder is basically, first one is string builder equal to R, and then string builder dot append. You will append that word, and finally you return sb dot toString. Then this, from the string builder you return the entire word. So basically this will be appended with this one. Okay, that will be the result. Is it clear?
Yeah. Yes. Yes.
Yeah, basically you, if you give all the powers, like you can use any functions, anything in the available. So then how do you solve this? This is all the why we need to ask this function, this program or this algorithm in the interview. If I ask this interview, what is my motive here, what is my motivation here is, my intention here is to find out how many methods you know about the strings. Have you really worked on the strings? Because I'm giving the full power. You can use append, you can use string, you can use strength, you can use index of, you can use substring. These are the very common methods available in any language. I want to know how much you're familiar with these functions, and I want to know whether you can solve this. How do you solve this? Right? So, and also one more thing is it says files, right? Another thing very important, even I got in couple of interviews like in Amazon or somewhere, file manipulation, right? How do you open the file? How do you close it? What are the, things to do? How to read the line by line, right? So this is a file with multiple lines. So how do you how do you read line by line? How do you process it? So that is also something I want to I want to examine on in the candidate. It's not like, it's not algorithm. It's not algorithmic problem for sure. You're not in using any particular algorithm. It is just a coding question. There is a difference between coding question versus algorithm question. So because we are not inventing any a new way of doing or any some logic here. We are just of course we are just writing the logic, but not avoiding any using of existing system methods. Right? We can use any of these available functions. Is it clear?
Yeah.
Yes, Suresh.
Cool. So how now first the next thing is how do you read the line by line? So now so we solved for one line. So let's say if it is a file, right? File readers are available, and in the file, how do you do that? Basically, you open the file and you put a for loop, and that file reader will tell you like read line. Read line means it will read the entire line and then it will give it to you. So there is a in the file there is a new line character. So let's say if I say like this, right? So these are in a single line. If I just click enter, that is putting in a separate line. That means there is one indicator here which is not visible to our eyes. There is no visibility, but there is a new line character here. That means this is one line and this is separate line. So file readers can understand, if I say read line, it will give you one line. If I say one more read line, it will give the next one. If I say one more read line, it will say end of the file. The only two lines available in the input. So that file readers already have that capability. Okay. We just need to use the capability. We no need to worry about the whole thing. We no need to worry about new line characters. We are not manipulating at the character level. We are manipulating at the lines and strings level, right? So simply we can do that. So I can show the algorithm here. Yeah,
Suresh, one quick thing.
go ahead. Yeah.
So let's say if at the end of the word,
Mm.
like it's like a 5 character word, but it
Mhm.
got broken
Yeah.
up to 3 characters,
Okay.
right?
Yeah.
Then in that case, how do we dynamically know like where is the last index of that space? So that's difficult to identify, right? So
Yes.
right now we put it as -1,
Mm.
but so how do we go with that route?
Okay. Okay. I will explain. So let me. I'm just running for the input here. So we will see if we have that exact use case. Okay. So is it still building? Okay, still building. I think it's taking long time here. We can build here. So what you're saying here is, sorry, let me open the code link. I think what we discussed will cover that case as well, but I will show you with an example. Okay, here is the test string, text trimming. Come on. If I run this, what why the running is okay, now I can run. So now look at this. So we have the input like this. Here is the input, right? Now look at the first one is less than 40 characters. We are just printing less than 55, and the next one is uh, is this one, and
Greater than.
yeah, greater than 55. So now let's look at that. So we can take this word. If this is what Venkat is saying, let's see how many characters we have. So we have 101. So let's say all the way to 40. Okay. So we got until
Yeah,
she,
right.
and here they simply attached it, right? Like where is that? She here. Okay. Okay. 40, but we did not see the she. here, right? Am I missing something? I don't know. But let's say, so what we are saying is, let's say we have something like this. Um, Something like a big word, okay? Or let's say counter, okay? This is the word. Now, what you are saying is we will cut all the way to 40. Now it is COUN or COU, right? So what was your question now?
Yeah, COU, right?
Mm.
Now it is like a meaning, it is not meaningful word
That's
if you
right.
see
Yeah.
the
Yes.
end word.
Yeah. What are we doing now?
Right now we are earlier algorithm, I mean, earlier code what we have written is if we encounter last one single character, then we'll trim it out.
No.
Now it is uh
Look at this. Last index of a
last
space.
index. Okay.
Last index of a
Oh, okay, okay, okay,
space.
okay.
It's
Last
not.
index
No, it's
I
not
got it.
last index of the string. It's from the resulting string. Whatever you have here. Let's say we have B and H. We don't know. It could be H means it could be hat or it could be house. We don't know what that H and the other word, right? So from this
Last
word,
index of
last
space.
index
Yeah.
of the space. What is the last index of the space?
Hmm.
This is the last index of the space.
Yeah.
That one minus one.
Correct.
So
Yeah.
here
Yeah.
last index of the
Now I
space,
think it will.
it will go all the way
It
to
will
here.
work. Correct. Hmm.
Okay,
Got it. Got it.
got
Yeah.
it. You got it, Taran, right? You also got it.
Yes, Suresh.
Cool. So that was the logic here. That's why we need to add one more line to find out what is the last index. Let's say, okay. So here is the thing. So now here is the full string, and if I put it here, so if I go all the way to all the way to 40 is she. And okay, so now we don't know whether it's a correct word or not. We don't know. It's she is a correct word. We are at the correct word. We can simply add read more. No problem. It's a user can easily understand, right? They can simply, if we put here, you can understand here. Okay, Amy Lawrence was proud and glad, and she read more. It's good, but for the algorithm, we don't know whether this is a correct word. This is exactly a proper word, or half of this big word. Let's say it is water, WATER. So you cut all the way to three water, WAT. The algorithm doesn't know whether the last word is a proper word or a broken word. You got it? It's a she is a correct word, but an algorithm doesn't know, right? You cannot say, oh, take this character, and you can still write in something. There will be some tool out there. You can take this character and verify whether this is a correct word or not. If this is correct word, you can keep the word. If it is a broken word, if it is not, something like what is not a word, there could be a word or there could not be a word like what, WAT, then this is not a correct word. Then remove this space. You can add extra logic like that, but here in our algorithm we are not doing that. We are simply every time when you cut for 40 characters, we are simply finding the last space and then cutting the entire word and putting the read more. You understood, right? Why you understood why
Yeah.
we removed the she here? Because algorithm doesn't know. You cut exactly at the she, but algorithm will find the last space and cut all the remaining four characters. Now we got the read more. Okay, I hope it's clear, right?
Yes, Suresh.
Now
Yes,
let's look
Suresh.
at the third character. Now third is exactly, I think it is exactly 55. That's why we did not even modify anything. If it is exactly 55, yeah, look at that. It's 54. It's fine. It's less than our count. Even if it is extra character, that is still fine. So we simply put without any modification. So now next one is this one, very, right? It will cut all the way to 54, 55 characters. First one is 40 characters. Sorry, 40 characters. Yeah, 40 characters. Do you see that, like hyphen ve? I don't know what is that. It's a very, right? It's like very, very great, very, very great, many, something like that. So here what we need to do, similarly the same algorithm. So we just need to remove the last word until you find a space. This is the space. We found a space after that hyphen symbol, right? So remove that entire thing. We should not remove hyphen or other thing, because we will just remove only the last word and the space before that last word. After this, you just add the read more. That's what we did here. Okay. And the last one is the same thing. We just discussed about it, right? Tom's mouth watered for apple, and but so it's the last word. So is it clear? Now, how are we doing in the files wise? Like we are taking this is a text file. This is a txt file in the algorithm available. So we are providing this entire file, not a single line. So here is the algorithm. Let me zoom a little bit. Okay, is it clear now? I can zoom a little more if needed. Okay, is it clear? So what are we doing? In every
Yes, it's clear.
language, this is a C sharp I used. In every language, you can write in Java. Every other language has file operations. This is a reader. Stream reader is something we use. So file dot open text. This is the method that will open the file name. So we are providing here main method perform text trimming, and here is the file name text trimming dot txt, right? We provided the file name, and here is the file name, and we are opening the file. So the stream reader, what this does is it will read streams. It will read the entire stream. Basically, it's not one line, it end of the stream. So while reader not equal to end of the stream, if it is, these are the functions available. So end of the stream, if it is not the end of the stream, go here and then take one line, read line. So we are taking one line here, and if the read line is null, continue. The line is empty, let's say you have empty, for some reason you got empty line, you can continue to the next stream and read the next line. If not, what we do is simply the same first checking. If the line is less than or equal to 55, if it is less than or equal to 55, we no need to do any operation. Simply console.write line, write the line, and continue. Let's continue to the here. Stream is still there, and read the next line and do here. Now, let's say the line is greater than 55, right? Trim the line to 40 characters. It's exactly the same thing what we did. So line equal to line dot substring. We are not taking any string builder yet. So we simply we took the entire line here. Now we simply override the line with simply 40 characters. So starting from 0 all the way to 40. Now here is the space index. This is what I'm telling. Space index. We need to find the index of the space from the last. So line dot last index of space. So line is the actual line until you cut the 40 characters, and here is the format. Here is the syntax of the last index of method in C sharp. So line dot last index of space. Now you got the last index of the space. Now what we need to do? We are taking a string builder. So this is where I will ask the user, the interviewer, why you take the string builder? What is the advantage? Like we can have a lot of conversations between candidate and the interviewer. What is the pros and cons of string? What is an advantage of string builder? Okay, we will discuss those as part of the interview. So now, SB, we take the string builder. We took the string builder. Now Space index not equal to -1. This is very important aspect. As I said, let's say I'm giving you a string. I gave you a really big word without any space, without any even single space. What happens? You don't get any space in index, so it will be -1. So if it is -1, right? So there is no space. You cannot even cut it. So you just add as it is. You just as it is, and then you put the read mode. But if you have a space, if you have some space index, then line dot substring starting from 0 all the way to space index. We are not putting space index -1. Do you know why? The reason is substring syntax is different in C sharp. Substring syntax is where to start and how many characters we want to extract. How many characters? It's substring has the syntax like that in C sharp. It's not like from where to where. Substring in C sharp. Okay. Yeah, we can see here. See, get first 12 characters substring from the string. So here is the big one. Mahesh Chand is the founder of C sharp, something like that. What we are saying is, so 12. So if we say the index of the space is 5, or let's say 10, that means we need only 10 characters. It's always the index will be the in way that the characters count is less than 1, right? So it starts from 0, right? So that's why it will be like that. So it will take 12 characters from the beginning. So similarly in our character, so let's say the space index is 35, right? That means 0 to 34. It will take all the way from 0 to 34. 35 characters means basically 0 to 34. That is 35 characters, right? So we are appending into the string builder. So we take that and we append to string builder. Now what we are doing is we are also appending three spaces and then read more. Finally, we are printing the sb.toString. We are printing the line. And then we are going back and taking the next line and we do the same program. Okay, is it clear?
Yeah.
Yeah.
Yes, sir.
Cool. So any
So the
idea? Go ahead. Yeah.
last index of returns -1 if there is no space.
Yeah. Yes. There is, if there is any no space. So we can try that option if you want. Let's say I want to give something like this. I want to give without any space. Example here. Oh, I can't modify this. Oh shit. I need to go from my account. So if we go to my projects, yeah, if we don't have any space, right? We no need to cut. It's a really big 44 or a really big 40 character word. I don't know. There will be some words which is 40 character word, right? So this is something like that. Text trimming. Up. No, I don't want that. It's opening a different program. Here is the text trimming. It's still opening. Okay. Number 9. Yeah, text trimming here. Sorry, it's a little bit slow here. Website is slow. So let's discuss in the meantime. Let's discuss string builder and string. Anyone know the differences and what is the advantages of using string builder versus string?
String is immutable,
Hmm.
whereas a builder is mutable. We can append characters to string builder.
We can also do to string. What is the problem? We can also the string also supports plus. You can use just plus character. We can add strings. So why we really need to use string builder? What is the advantage? What is mutability and
Uh,
immutability? What is mutable? What is immutable? Yeah.
so string, right? String is not mutable. So once you create, entire object will be created at once,
Mm-hmm.
right?
Yeah.
If we want to create an add or anything to that, again we need to create a new object, and finally uh, we need to create a concatenate both of them and create a new object
Yeah.
that will require another object space memory. So whereas the previous two strings has a two memory locations, right? That will be gone. So basically, we are creating a multiple memory locations. So if
Yes.
we are doing manipulations on the string,
That's correct. That's correct answer. So did you get it, Tarun? What is that mutability, immutability?
Yes, yes.
So I'm making up a word here for you for the use case. So let's look at this. See, this is a really big word without any space, and even let's remove this. Let's remove the comma. So this is a really big word without any space. But what we are doing is we are simply cutting at 40 characters. This is 40 characters until 2 here. Where is that? Until here. And then we are simply appending the read more because we did not find any space, last space from here, right? There is no space. So what we can do? We can simply put the read more. That's what the algorithm here, right? So space index is -1. We did not find any space from the last all the way to beginning. It went all the way to beginning of the string. We did not find any space. The space index is -1. So since we already cut to 40 characters, no problem. We can simply add the remaining 15 characters. This is 15 characters, right? So this 40 plus 15 finally will print the 55 characters. Is it clear?
Yeah.
Nice. Okay. So now coming back to the discussion, what Venkat said is correct. So what is string mutability and immutability? So if I understand from my learnings couple of years ago or in my studies, so basically when you create a string, right? Let's say here is a string. The string um, here we are overwriting the string. Look at the line number 30. We are taking the substring 0 to 40 characters and putting in the string. This is expensive operation. The reason is initially this string will be created in the memory in one place. Now we are subtracting or we are adding or we are overwriting. We don't know it. Let's say your substring and we are also adding another 30 characters or 40 characters. So that's what it does internally is it cannot append, it cannot change that particular memory locations in the processor, in the RAM. So what it does is it will just erase that. It will take one more memory location in the absolute memory. If you look at the RAM and memory addresses, the new string will be created in a different space in the memory, in the RAM, while you're running the algorithm. So that's why if we are keep modifying the same string, it is an expensive operation, and internally it will take more time to compile or not to compile, to run your code than using string builder. So what string builder does is string builder was designed in such a way that it will be able to append, it won't create new memory location. I'm not sure how they did internally. We don't know about the internal details of these the implementations, but I assume it will allocate more memory than needed. So basically string builder, now what we are doing, string builder, we took the string builder, we appended this line 40 characters or all the way from 0 to space index -1. So this will be appended, and again we are appending this another read more. So basically it won't um, it won't create new memory locations. It will just append at the end of the string. So there is a performance benefits. So if you are calling, if you are using these words, that will impress the interviewer. If you say performance benefits, and that's the reason we use string builder, so that will be benefited in the interview. Okay, so we don't see in this simple algorithm, you don't see the difference. You can still use string here, but if you are writing a really big string manipulation, you are writing a dictionary kind of algorithm or something like string manipulation algorithm, then we have to use string builders. Okay, cool. I think it's clear, right?
Yeah.
Very good. So I will send this link. Just I will put it here in the chat directly, and also I will share after the meeting. So because I may send a little bit late. So okay, those are the string algorithms we discussed so far. We already covered a couple of algorithms. Let's review kind of algorithms we covered. First one is palindrome, right? Couple of weeks ago, we discussed about palindrome, unique permutations. We need to check if the string has unique characters and permutation. Given two strings, write a method decide one is a permutation of the other. We discussed this. And max occurrences, given a string, find character that occur max number of times. We covered this. And URL encoding. This is also very important. So putting for every space, you need to put %20. It's basically manipulating from the back, right? So that is the main logic here. Um, and string path matrix. This is also we covered. If you ask for the path A, B, C, B, is it there or not? This is also very interesting algorithm. Um, but of course, it is tricky. I don't really ask this algorithm in interviews. It's tricky algorithm. It's a DFS kind of thing, depth first search. We covered that. And substring index. So search for occurrences of a word W in the given very long string F. If found, return the start index is basically substring. So we just use a substring in our algorithm. So how do you implement that? So that's what we implemented, substring algorithm. And super reduced string, this is very interesting algorithm, right? So we discussed this kind of it's a kind of candy crush game. If you have multiple strings with the same multiple characters, that will reduce. These are the things they will use in the transformations, basically. um, Text manipulations, or what we call, I did not find the correct word. Encoding, yeah, encoding, decoding, string encoding, decoding, they will does this because it will take less memory to store this rather than storing the entire string, right? So sometimes what they do is, so in the encoding, let's say you have something like this, you can represent this in a different way with using less number of characters. Let's say you have a, and this is b, 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 and this is c, 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 something like this. You are taking these many characters, right? Now you can represent the same thing in a different way. How many a's here? 1, 2, 3, 4, 5, 6. So you can represent like this: 6a. And how many B's? 1, 2, 3, 4, 5, 6, 7. 7B. 7 B's are there. And then 1, 2, 3, 4, 5, 6. So 6 C's are there. Now you can send this over the network, and simply the other side will encode. And oh, you are saying you want me to write 6 A's, you want me to write 7 B's, and then 6 C's. Then it will convert back to the original string before it is giving to the consumer. So all these networks is always, they will try to reduce use the bandwidth and reduce the information that they can send quickly. All this encoding, decoding will be helpful for that. So these are the some of the techniques they use to reduce the size of the payload that you are sending from one end of the network to the other end. Okay, so that's why we need to learn these kind of things. This will be helpful, how to reduce the how to compress, right? It's a simple algorithm. We always know from the day you start the computer, you always know about zipping. You zip the file, right? How it will compress the content? How can you compress? If you are putting items in a bag, you can push it, but you can't even compress that much, right? So here it's information. So they will do something like this. That's how they compress. They have tons of algorithms. They will scan the files, and they will see the repetitions. Even in the photos, if you look at the OneDrive or Google Drive, they will find the similar photos, and they will compress. If you copy the same photo in different 3 4 folders, technically they will store only one image, one photo, and they will have the references. Hey, this photo is there in this folder, that folder. If you go to any of these folders, you will see the same photo, but it's not three copies. They will maintain only in one copy behind the scenes. How they compare? How they know that same photo is there? That is the algorithms. Those are all lot of tons of algorithms they will run behind the scenes. They will see how they can compress the files, compress the contents. It's a big vast subjects on its own, actually. So it's a very small thing we learned here, how to reduce a given string. Yeah. Any questions, Venkat? It looks like Tarun left.
Tarun has left, it seems.
Yeah,
Yeah.
maybe he has network issues. So is it clear what I'm
Yeah,
talking?
yeah. Yeah. Encrypting and decrypting. Yeah.
Yeah, encrypting,
I'm
decrypting,
good.
encoding, decoding. It's so fascinating when I'm learning this. This is something I don't know. And when my studies, when I go to these
Oh,
classes in Saturdays, people from
mm,
Google, people from Amazon, people from Facebook, they use it to
yeah.
explain all these. Oh my gosh, I think, oh, this is how the things are working behind the scenes, right? I was so
Mm,
fascinated and realized, and you know uh, the great algorithms. Otherwise you will be
mm,
in a world where a lot of duplication, right? And
right, right.
bandwidth,
Yeah.
you never be able to see this much fast internet speeds, and this much
Mm,
kind of the videos or the blogs. You will see very fraction of milliseconds if you'll see the content. How this is all
right.
possible? Because this is all possible behind the scenes. There are a lot of algorithms are working to reduce the size of the payload, and to use the bandwidth. So they don't want to clutter the whole bandwidth when you are putting showing when you are opening in the mobile phone or any browser, any websites, right? They
Yeah.
always think about how to reduce, or how to compress, how to optimize. Basically, optimize is the best word. So how to
Yeah.
optimize the content, um, so that they can deliver faster, right? That's what we
Yeah.
discussed, and we discussed couple of lowercase methods and swap case and reverse word, how to reversing the words, and text trimming. This is what we just discussed. So I hope we covered a good number of algorithms in strings. There are still a lot of tons of algorithms. So
Yeah.
yeah, if we have time, we can go to string linked list. I thought of starting the linked list, but it looks like Tarun left. Let me see if he messaged anything. If he's joining. If he's not,
Yeah. He joined back.
oh, he joined. Okay, cool. Hey, Tarun, do you have some network issues or?
Yeah, I lost my con.
Oh, okay, okay, cool. So yeah, I just glanced about different algorithms we covered. So I'm talking about the encoding decoding thing. I just when you're disconnected, I was saying, like, without this encoding, decoding, and encrypting, decrypting, and also optimizing algorithms, we will never be able to see the world what we have right now, with a fast bandwidth, which is with a great internet, and you will see the content in a fraction of seconds, right? You can see YouTube videos and blogs and Facebook net. Everyone does this kind of optimizing the content and delivering really fast to the consumers. Okay, so that's what I'm about to say. Yeah, so we discussed all these algorithms. These are few in strings, but there will be tons of questions on the strings. So the best thing is at least learn few things completely and have full confidence and have some idea how to tackle, and then you can go ahead and go to Geeks for Geeks and just try a couple of more algorithms on every concept on the strings. Okay. So stacks and queues, it's not queues, Q-U-E, right? I think the spelling is wrong. Q-U-E. Yeah, stacks and queues. So this is pretty interesting concept as well, but these are just data structures that we use in other algorithms like linked list, trees, graphs. If we go down, there will be a lot of places we use stacks and queues. So I hope you guys already have some good understanding of the stacks and queues, right? So stack is last in first out, and queue is like last in
First in, first out.
first out. Whoever, whichever, it's just a queue. Whoever
Uh,
in the queue, it will come out
st-
from there. Is that right?
yeah, I think reverse probably.
Reverse
Yeah.
last in. Okay, we have
First in, first out is stack.
first in first out is
Sorry, first
no,
in, you are
last
right.
in
You are
first
right.
out.
Last in, first out is the stack, and first in, first out is the queue.
Yeah, yeah. So LIFO, we call LIFO, right? Stacks is LIFO. Last in, first out. Whoever is on top of that stack, that will be removed. Whereas in the queue, whoever is the first in the queue, first in, first out, right? So pretty common algorithms here. But there is a tricky here. Sometimes people say implement queue using an array. So queue has many of our languages, C sharp, C, Java, we already have stack, we already have queue. But people will trick you and they will ask you, don't use the inbuilt queue, create a queue class, create a data structure called queue, and that will using the array. So there are some links over there. I did not implement, but there are few things. And implement a queue using a linker list, this is also another thing. I think we completed in linker list. We had this in queue, so we'll cover that. I think if I go to linker list, here is the linker list using a stack using linker list. And where is the queue? Yeah, queue using a linker list, we covered those. So very interesting how to build a stack data structure using a linker list, how to build a queue using a linker list. We will cover those in the linker list chapter. Basically, you will build the methods. What are the methods in queue? What are the methods in stack? Pretty standard methods. We will implement those. And yeah, here is the one: implement stack using array. Yeah, these are the another little bit tricky algorithms. Implement queue using array, implement stack using array. So I would recommend go into these links. I will whenever you have some time. It's not super important, but something we can something it's better to learn. Some of the interviews you may get it. So I implemented these two, queue and stack using linked list, but I haven't implemented with arrays. So but I got this question in one of the Microsoft interview. I think when I'm is it full time or contracting? I don't remember. I attended many times. So in one of the interviews, they asked me to implement queue using a circular array. It's so confusing. It's not that easy, but we have to. Yeah, we'll see if we can practice later. But I'm putting these links here. Whenever you have some time, please go through that. Okay. So please copy and paste it in your notes. Okay, I put it in the chat. So now let's jump into the linker list. Are you guys okay, or do you have like any other thing? If do you want me to start next week, or shall we start the first one? Is it okay?
It's okay, Suresh,
Very
for
good.
me.
Okay, Venkat, is it okay? Shall we start the basics?
Yeah,
Cool,
that's
cool,
fine. Yeah, welcome.
cool.
You can go ahead.
So basically, linker list, right? We'll talk about linker list first, and then discuss. So why we need linker list, and what is the pros and cons compared to arrays or any other data structure? Anyone can answer what is the difference between linked list and what is the advantage? I'm trying to find my pen here.
Linked list stores the address of next element.
Okay.
So whereas array is like a group of elements
Yeah.
which contains only value, not address of next element.
Yeah.
Most of the times, like in linked list, like for inserting, deleting, we need to replace only the address of next and previous element.
Yes.
It is the advantage.
Yeah. You can insert elements easily. You can delete the elements easily. Right.
Yes.
Yes. That's very good difference. Yeah. So
And the thing is, one more thing is,
yeah.
uh, from the array size, sorry, array is a fixed, right?
Yes. That's right.
That is the major issue with the arrays.
Yep.
So whenever we want to add or delete, we need to either copy entire whole data into a new array and do
Hmm.
manipulation. So that is a extra work if we want to go with the arrays.
Exactly.
Arrays are fixed,
Exactly.
whereas linked list is not like a dynamic arrays. You can say
Yeah, dynamically you can increase to whatever we want. That's right. So
we
that's
want. Yes.
yeah. So how many elements we want, we can increase, and we will provide that expanding capability. That's the main differences. So why we need to use arrays versus linked list is that so it is at the time of initialization. Array is like at the time
Yeah.
of initialization. That means at the time of writing the code. It's not like compiling or anything. At the time of writing the code itself, you need to think, hey, should I take the array of 100 or 1000? You are limiting yourself as a developer, but
Correct.
you're not able to give us something like, hey, tell me how much you want me to save, tell me how much you want me to store. You cannot take that input from outside, from the customer, or from the from the end user. We cannot take that input and allocate it. Just like as if while coding itself, you need to decide what is the full size of the array. That is the main limitation. And the second limitation, what you said, is correct. So you cannot insert element in the middle of the array. Either if you want to insert, you have to shuffle all the elements right side to the next element. So let's say you have 1000 spaces and you have 100 elements, right? So if you want to insert an element, let's say at the 50th character, 50th position, remaining 50, you need to shuffle those, right? You cannot insert at a particular location. And as you said, the deleting is also problem. If you want to delete, you have to reshuffle all the elements. Otherwise, you will see a gap there, and you're wasting that memory, right? That's a problem. So you can simply put something like -1. Let's say you're having a positive integers. Instead of deleting, let's say you want to delete number 5, you can put -1, and your algorithm says if it is -1, don't display or just ignore. You can write the algorithm. You can still, you no need to shuffle this. You can simply write some algorithm that will ignore the value, negative value, and you put -1 or -100 there, whatever you want. And that way you can ignore, you no need to shuffle. But what are we losing? We are losing the space. We are losing that memory, right? That's the problem. So in order to use that space again, you need to shuffle the elements. So this is an example. So whereas the linked list provide the full capability to solve all these problems, you can simply start with a simple address. So linked list always have head, right? The head is a pointer, h is a pointer that will always point the first element in the linked list, isn't it? And array have another benefit actually. There are some benefits. Every time, every data structure has some pros and cons. So array has a benefit where you can, you know, how what is the full size. That means how many elements, how many, how what is the full space you initialized, and you can also know the length. So size will give you the full. Let's say 1000 elements can be fit, but right now you have only 101 elements. So this is the size. This is size, and this is the length. So size and length. But in case of linked list, it won't provide by default. You have to maintain, or we have to maintain on our own, right? So here there is no concept of size. Here you can increase the size unlimited as long as you have the RAM or the memory available in the device where you are running. So you can increase the size, you can keep on adding the element. The size, there is no point of size, always length. So how to calculate length? It won't give you automatically. The linked list is simply an address. It will just tell where is the first element. That's it. It's a kind of chain, right? We have chain in our necklace or kind of something. So you have to first touch the first one and then count from there. So you have to maintain the length. We have to maintain on our own. How many elements in the linked list? If you don't maintain the length, you need to count every time you start from the beginning, and you need to count the number of elements. Okay. And the other thing is, you can add elements. You can insert element at any point. You can insert in the middle of the, you can simply change the addresses. You can insert the element in the middle, and you can also insert element at the end. So you can also insert element at the beginning. So these are all algorithms we will discuss. So, and another thing is, the main drawback compared to arrays is direct what is it, direct pointing or direct jumping into a particular element. Let's say I
Correct.
want to give you 60th element in the array. You simply say a of 59. That array a of 59 will give you 60th element without even worrying about from the beginning. It will directly go to that 60th element and it will give the value. But whereas in the linked list, if I'm asking 60th element, right, we don't know. We need to go from here, from the head, and you need to count as you are going. This is first, this is second, this is third and fourth, until you find 60th. If we did not find 60th, you will say there is no 60th element, sorry. Of course, if you maintain length, it's a simple technique. If we maintain length, now let's say 1, 2, 3, 4, 5, 6, 7. We have only 7 elements. You're asking me 60. Sorry, man, I have only 7 elements. I can't give you. You can simply reject before even navigating. But if you don't have this length, if you are not maintain this length, there is no way that we know whether we have 60 elements or not. There is no way. Only way is you need to go and search for the, we need to have a counter, and the counter, first element, second element, third element, you will go all the way to 60th element. And if you find the element, return the value of that element. Okay, that's the differences. Once you have these basic differences, it will definitely help you while you're solving the problem. So sometimes you will get a problem where they don't give you any clue. They will say use whatever the data structure best fit for the algorithm. So it's based on the problem we are solving. We need to find whether the taking the linked list is better, or taking a stack is better, or an array is better. There are some certain cases you need to have a choice. Like, you will have a choice of taking an algorithm, taking a data structure, but we need to think strategically. We need to think which is best for our algorithm, best to solve the algorithm, right? To basically, what is best? What is meaning of best? Either reducing the complexity, right, time complexity, at the same time reduce the space complexity, right, or sometimes both, or sometimes at least one. So sometimes what happens is, if you are taking an extra data structure, array, or linked list, or queues, stacks, that means you are taking an extra memory. You are not reducing space. But what is the main point there? We are trying to reduce the time complexity, right? Sometimes you have to take it irrespective whether you